Here on September 9th, 1997, to run through the Coyote test rig setup and a test with the Duralcan drum. First I'll run through the basic features of the rig which we've used before to test the aero blade brake unit. First, the Coyote skates mounted to the rig. There's a mechanism back here that allows us to loosen and tighten this lever against the frame so that you can subsequently engage the wheels and they'll spin with the drum when it spins. The dark dots you see on the what essentially amounts to sanding drum are the magnets which are picked up by the speed probe, and you can thereby measure wheel speed. Up here to supply representative cooling air that is calibrated to the speed of the wheels. We have a blower rig with a plenum downstream and a screen to somewhat equally more distribute the air. Also have a piece of thin plastic or Kydeck here to help guide the air in amounts around the blunt surfaces formed by the front of the rig. So basically we get representative cooling air flowing around the skate as it's rolling at a essentially an effective speed of 20 miles an hour. As far as instrumentation is concerned, we have up inside under the boot an infrared thermocouple which is mounted to point at the surface of the brake drum which rolls against the wheels. Down here we have the same well, not the same, but another copy of the infrared thermometer which looks at the wheel surface. Inside the brake unit itself we have thermocouples. There it is. Thermocouples mounted inside the brake bands for the left and right sides. We also have pressure probes here and on the other side here. There it is. And we use those to calibrate the airspeed as produced by the blower. And all this already has been done, so basically the setup that we have allows us to do a number of tests without having to change anything. Pressures are measured here with pressure transducers. We can switch between the right and left pitot tubes on the skate, and we had done that during calibration tests. Then the 4 thermocouples, the 2 for the brake bands and the 2 infrareds, 1 for the wheel and 1 for the drum, come back here to this junction block, and then everything comes back over here to an Omega Engineering data acquisition card, and then basically a small PC gathers and stores the data. And I'll zoom in on the display so you can possibly see what we have set up there. You have the brake drum infrared's channel 1, the left brake band's channel 2, right band is 3, center wheel infrared is 4. The total pressure, or the pressure produced by the airstream, which we use to calibrate against the speed, shown channel 5. The measured motor speed is channel 6, and then the air between the two, which is one of the parameters we use to calibrate, shows channel 7. Channel 8 is another thermocouple which basically isn't used for this test. Switch for the motor here, and one more item is we have the weight set up on the actuation mechanism so that the weight can be turned in and out to increase or decrease the amount of braking force that's applied. We also have 2 dials here which allow us to determine what the angles of the main actuating mechanism and also the wire forms are, and that way we can determine what the actual braking force is. So I'll back out here and get the data acquisition ready to go, and then we will start up and do a test run. Alright, here we're ready to go. First thing we'll do is turn on the motor, making sure that the wheels are off for the time being. Basically what I'll do here is let the motor run for a short period of time. The data acquisition gathers readings every 2 seconds. So we effectively find out what the no-load speed of the motor is. Alright, now we'll go ahead and engage the wheels against the brake drum. Basically what this does is you've got some rolling resistance for the tires, which slow down the motor, so we can subtract that reading from the readings we get when we apply the brake, thereby only really getting the net forces which are produced by the brake mechanism and not including the rolling resistance. So we'll tie that down a little bit. Once again, let it run a little bit so we get calibration point. One item I did forget to mention earlier, I wanted to make sure that all the airflow parameters were as close as we could as possible, and that means rotating the front wheel with escape to make sure that the airflow through the frame is representative once we turn the air on. So we've added a small cone-shaped roller between the front two wheels. If you look carefully, you can see that the very center of the roller tapers down very close to a small diameter. The reason for that is we didn't want any additional surfaces contacting the center wheel, which would bias or throw off our surface temperature measurement of that. Essentially, if that roller had a flat surface and rolled against the wheel, it would tend to soak some of the heat from the wheel and give us a low reading. Alright, so we've got that set up and going. It's been going long enough. Now we'll come around and turn on the cooling air. And at this point, there is no braking force being applied to the wheels. Now we have the cooling air going. Take a look at the display down here. One of the thermocouples on the bands had been giving us some trouble. Well, basically, gang, I had the brake going with and without cooling. So during the test, the brake was applied. So what we'll do at the end of the test is take the brake off, get our calibration point that we need. This is the Duralcan drum. You notice that it's spinning inside. If you look carefully at the rear wheel, you can see that it is out of round somewhat. There was some concern as to whether that would really cause a lot of additional bouncing, and it doesn't. The brake mechanism simply rotates just fine. I mentioned we were having some trouble with one of the thermocouples, and that being for the exit brake band. Basically, that's why we have two of them. Give us some redundancy because measurement of either one is just fine. You see that the brake bands are, for this particular test, are getting up around 60 degrees C. I'll let you do the conversion. The surface temperature of the brake drum that runs against the wheels is also up to about 60 degrees C. But interestingly, the center wheel, infrared, it's about 20 degrees lower than that. And the reason being, even though you have a hot surface for the drum rolling against the wheels, it's only in contact with them a short period of time. So what you effectively get is something lower. And really, I guess at this point, it's a question as to how hot the wheels can get without really causing excessive wear, simply because they'll get hot for an instant and perhaps that hot material would get scrubbed off, but basically there's no way to tell for sure at this point. I'm going to wait a few minutes and see how long it takes for this to come to steady state. So we'll pause here and keep the test going. Okay, we're back after a few minutes. What I've done, basically I've added a little bit more weight to the actuation mechanism. I wanted to get a little bit more loading on the brake drum. Basically what you have here is a scenario that gives you about 5 pounds of braking force continually. We've been running for quite a period of time here. Bring you over here to see what sort of results we're getting, and this will all have to be tabulated and put together with the rest of the data. Basically, if I can get this to focus on the screen, brake drum infrared is reading about 96 degrees C. The left brake band is slightly lower than that. Right brake band signal is in error, and the center wheel infrared is reading about 49 degrees centigrade, which is, as you can see from the bottom, the ambient's about 27 degrees C. We got about 22 degree temperature rise on the wheel, and also you can see the motor speed there. So essentially, these are the sorts of tests we're running. Run with the Duralcan. We've already run some with the steel drum. Surface of the steel drum that rolls against the tires is definitely getting hotter. There's some question as to how effective the cooling fins are inside the drum as well. Part of the problem we've been having is that the infrared temperature sensors see a pretty wide area, and it's fairly difficult to try to get it to see only, for instance, the surface of the drum. So we're putting this information together with the thermal model, and we put them together and determine what the quantitative performance is for both the Duralcan and steel drum. And we'll be in touch with you soon.